Hello everyone and welcome to this section. In this section we're going to explore different color spaces, which is very important in our image analysis in general in self-driving cars. So the first step or the first color space we're going to be covering is RGB color space, which is one of the most famous color spaces, which is simply we can represent any color or any pixel within an image in RGB basically, which is red, green and blue, okay, in a very simple form. All right. Okay, so how can we get other colors? So if we only have R, G, and B, we can actually start to mix some other colors together to come up with different, for example, like they come up with yellow color, for instance, or come up with, let's say, pink color, and so on and so forth. And that's pretty much how can we represent an RGB color. So here we have our, this is kind of the blue, here we have our red, here our green, and we can start to mix them up together to come up with all the colors in the world that we have, okay? So again, it looks a little bit different, looks a little bit weird. So I thought, okay, maybe we can go to paint, to start, play a little bit with it to just get an idea of, okay, how can we represent different colors? So if you guys can open paint, you can just say, let's say, edit colors. Again, I don't want you to be confused with the hue, saturation, and illumination. We're gonna discuss different format. I just want you guys to focus on the red, green, and blue. So let's say if you want to have, let's say, pure red, we're just going to put 255. And that's pretty much so just, understand, okay, now we're looking for only red. And that's why you will see that we only move to red, okay. What if I want, for example, to have only green? So just going to put 255. That will tell us, okay, we'll take green color. Okay, what if I want, for example, to, let's say, black? That means 0. Okay, what if I want blue? That means 255. That will set blue color, which makes sense. And then what if I want, for example, like any other color? Okay, so what if I want, for example, yellow? Let's try 255 for red. And then for the green, we're gonna try 255. And that will generate the actual yellow color, which is kind of a mix between the red and green, okay? What if we set all of it as 255? That would actually give us the white color. The white color is when all the pixel, has like ones in it. If you guys remember, just for a grayscale, we had 0 indicates black, 255 indicates white. If we actually do that for colored image, for 3 layers, we come up with a color white, and so on. And then here, you guys can start to change it to just get an idea of, okay, what if I want to represent a gray color? What if I want to go down, for example, to represent like different colors and so on? That's where you get the different, let's say, kind of shades between gray and white. If you can, again, move this to here, it's going to show you different colors. It's actually really interesting. I'll give you like, like a real world practical, like representation of the different RGB colors. All right. Okay, great. All right, let's go back to our slides. And that's pretty much all what we need to know for the RGB representation. One important point that I want to clarify is that in OpenCV, okay, it's a little bit confusing. I don't want you to be confused. We're going to show you how we avoid any confusion. But in OpenCV, actually the color representation is a little bit different. It's represented in BGR, so the order is different. The green is the same, however, the B, the blue, and the red are mixed. In general, people use RGB, okay? OpenCV is a little bit mixed, okay? It has to do with a little bit of storage. How can we efficiently store numbers? That's not our issue right now. Our main point is it's kind of reversed. That's why you will see sometimes when you load images, you see colors are totally off. You will see the blue and the green, the blue and the red are reversed in a way, okay? All right, so that's the first color space. Now we know how to represent it. The second color space we're gonna be covering is what we call it HSV, okay? Which is hue, saturation, and value, all right? And that's pretty much what we can see here. Actually, HSV is very important. I actually personally like it because it's kind of, more intuitive, okay? As you guys can see here, we can represent the colors again in a cylindrical format, all right? And the different colors for hue, for example, it ranges from 0 to 180, all right? Some people represent to 360, but in OpenCV, we're gonna represent it to 180. Saturation, it ranges from 0 to 155. Value represents from 0 to 155. So what do you actually mean by HSV? So hue, that actually represents which color we're talking about. Okay, and that's why it's represented around the cylinder here. So here you will find this basically range, this angle range, for example, represent the yellow. As we move forward within the cylinder, we can go to green. We go moving forward, we can cover, let's say, blue. Move forward, we cover, that red region and pink region and so on, okay? And that's pretty much all the color representation on a 180-degree angle per se. So if you want to detect green color, for example, let's specify, let's say, like 50. If you want to specify, let's say, red color, I'm going to specify 0 and so on. That's based on the angle, I can tell you which color I'm talking about, okay? Perfect. What about the vibrancy of the color? We can actually change it by changing the saturation. And that's why here you will see the saturation, which is the S term in the HSV, that represents the vibrancy of the color, how vibrant the color is, okay? If it's 0, it's like dull kind of thing. 255, that means the color is so vibrant. All right, let's take a look. So that's the saturation. So as you guys can see here from the center, as you move forward, the color blue is it's like, adding way more paint. It's more to make the colors very vibrant, okay? That's what actually when you do, if you just go on your phone and change, for example, take an image and change the saturation, you will see that the colors becomes way more vibrant. Why? Because you're adding the saturation in there, which is my term in here, going from 0 to 255, all right? The last term we're gonna be discussing is what we call it the value, which indicates the brightness or intensity of the color, okay? 0 indicates it's very dark color. As we move to 255, that means more bright, okay? As you guys can see here, again, the value, okay, which is the value here, on the bottom it shows black. As we move forward, it shows like, with the actual true color as it is, like, the more bright as we move forward, okay? And that's pretty much how can we represent the hue, saturation, and value. Again, let's read it together. So hue is arranged in a radial slice, as we mentioned, around the central axis of neutral colors, ranging from black at the bottom to white at the top. And that's all the colors that we want. We can select from the angle, we can select which color. We can detect from the saturation. We can detect how the shades of brightly colored paint, how can we change the saturation to get, way more vibrant colors, way more saturated color, kind of, more paint per se. That's saturation. And then the value represents the brightness, how bright that image or that color is going to be. So dimension resembles the mixture of those paints with kind of, black and white. If you're going to go value of 0, that means it's totally like kind of dark. That's what we can see here on the bottom. If you increase the value, it actually becomes more kind of, like the true color. Okay, it's more kind of bright per se. All right, perfect. And that's pretty much all what we need to know when we represent the color in HSV format. Let's take a look at a couple of examples. And let's look at a couple of examples of conversions from RGB to HSV. So that's pretty much all the colors, as you guys can see here. So again, the hue is very important for us because it represents which color. Are we talking blue? Are we talking red? Which color are we talking about? So the hue color range from 0 to 180. Okay, some people represent to 360 degrees, but in OpenCV, we're talking about from 0 to 180, and that's very important. So number green, for example, is from 45 to 75. That's, the range of green. Here, again, I'm looking at the cylinder from the top. Okay, so that's the number green. If we're talking red, that's from 165 to 15. So 165 to 15, red. Blue, we're talking from 90 to 120. That's represent the blue color. Okay, all right. The next step is we want to convert, for example, from RGB to HSV. If you guys can follow that link in here, let's open it. And that we're going to show us, okay, kind of a conversion, quick conversion. Let's take a look. So let's assume that I want us, for example, to convert from RGB. Let's assume I want to convert just from red color. So I'm just going to set this to 0. And I set this to 0. I'm going to make it just pure red. Let's go and convert. It will tell me, okay, our hue, which is 0, H is 1, and V is 1, which means our angle here is 0. Let's go back. And you guys can see the angle 0 indicates red, which makes sense. Okay. In the same fashion, if you guys repeat, I try to just take a snapshot here. If we show, for example, the number green, so if you put 255, that would show us an angle of 120, which makes sense. Okay, why? Because if you take that number again, that number is represented in 360 degrees. Don't forget, again, I just tried to include all the information in the slides. Don't forget the half term. That means, we're talking about 60 degrees. So which makes sense. 60 degrees indicates green line, green color. What if you want to indicate blue? So if you indicate 255, again, 240 divided by 2, that means 120, which makes sense. 120 indicates our blue color. And you guys can go ahead and change, can go back from RGB to HSV, and that's kind of the conversion. How can we represent this exact same color in totally different color spaces? All right, and that's pretty much all what I have for this section. I hope you guys enjoyed it, and see you in the next section.